If you want to deep dive into Docker networking and get a complete overview of the internals of how it gets implemented with one host, and also understand how to launch multiple microservices which are interconnected together and automate your dev environments, which is a useful thing for everyone, including developers, DevOps, and even now the AI and ML engineers. So this is a masterclass series, and this is the third of the class. So you can find out the first two from the playlist available on YouTube if you're watching this on YouTube. And this is now made available to you as part of our open courseware. This is Gourav Shah from School of DevOps. Let's get started with Docker networking and Docker Compose. Let's get started with our learning session today. We'll start with Docker networking and then talk about Docker Compose. What are we talking about? Last week we talked about the building images part, and I've demonstrated to you by creating an image for an application called as Vote app. Now this Vote app is part of a larger microservices stack. What is that larger microservices stack? This is the one. This is called as a example voting app. This was originally created by Docker as their sample project, and this is what we are going to containerize. And let's say now we're talking about Docker Compose here, right? And it has 5 microservices. The vote is one of that. Then whenever you submit the vote, it goes to Redis. From there, worker pulls the vote, and then it could be .NET or Java, and then sends it to the database, which shows up the result. If you want to onboard a developer quickly on this project, they would need an environment to work with. How do they create the environment is where Docker Compose can be very handy. Docker Compose is like composing an orchestra. So you have different synchrony of music playing all around, and that's how you compose it, right? So that's what we do in this case. We are composing an orchestra of microservices, and that's where all these 5 services will come in. Let's say we have built an image for one of the application, that is Vote, and let's assume that the Docker files exist for rest of the applications as well. Provided that you have that, or maybe images, you can create a Docker Compose spec to connect them together. And Docker Compose comes with its unique features like service discovery and connection between two services. You can create an isolated network for that as well. Now, to understand all of this, you need to build foundation on container networking. And that is what we will get started with, a basic understanding of container networking. What are the different types of networks which are available, some basics, what are the defaults which are available, and how do you get started. Understanding of that is what we will talk about. So when we talked about Docker introduction, we said there are 2 features which are most important, which make containers possible. One is a namespaces, kernel namespaces we are talking about. There are 5, 6 namespaces out there: network namespace, IPC namespace, user namespace, and then there is file system namespace, and all of those things, right? And then we have basically the C groups as another feature which controls the resources. When we talk about namespaces, one of the namespaces is network namespace. That is what gives a container an isolated networking environment. How does that happen? The technology behind that is what we are looking at. And in case of Linux, that technology is called as a vEth pair. V stands for virtual. It's a virtual Ethernet pair out there. And the way it works is you have every container gets its own interface. On the container side, you look at it as ETH0, and there is a pair on the other side, that is on the host network, called as a vEth interface. So it will start with vEth, and it will have some random name out there, to make it unique. And let me actually demonstrate that by showing you how this works. And I'm going to connect to the same server where this is my Docker host. That's where my containers are running. And that is where I would run the containers. So let me start a container and show you how the networking would look like. So this is, I have a few containers running. This is part of the demo that I gave you, the other day. So this is the kind based setup. So I can delete this cluster using kind delete cluster, and whatever the name of the cluster is. Typically, it will be kind. I'm just cleaning it up, right? So there are three containers running. I'm cleaning it up and I'll show you from scratch how the container networking looks like. Let me launch a container now using docker run -idt. Give it a name. Let me call it as NT01. I'm using Alpine as an image and shell to start the application with. So just start something, right? So that is shell. If I go inside NT01, that is the name of the container. I see the ETH0. That is what we are talking about, the network namespace. How does it work? There is ETH0, then there is vETH interface on the host side of things. So every container that you create will get its own vETH interface, which you can also look at using ipconfig command, ipaddr rather. This is called as a vETH pair. How do you find out the pair? Pairing is you can easily find it out if you run ipaddr. So if you look at an interface, it has a pair that is on the host side, interface number 140. 140 is that vETH interface which is paired with 139 right here. That is what we are talking about. This is a FIFO pipe, first in, first out pipe. Basically, this is the pipe. So if you send something here, comes out of here. If you send something from here, comes out of here. That's as simple as that. And then that gets added to a bridge because you may have multiple microservices running together. We are talking about Compose. We want to connect the services together. And to do that, we need to have a way to have one container talk to another. Like this container talking to this one, or in our case, that craftist, sorry, the example voting application, this service will talk to this one, and so on and so forth, right? And this is the new version of the same diagram. So these services need to talk to each other, meaning these containers need to connect to each other. How do these containers running on the same host connect with each other is what we are looking at now, is through the network bridge, right? See, in the world of DevOps today, everything is abstracted. You have Kubernetes, you have what we call as a software-defined networking. That is what we are looking at. But earlier, you had to configure network bridges by hand. I have done that by hand in 2006, 2005, 2000, between 2005 and 2010. I've done a lot of network configurations like this, configuring bridges, configuring routers, configuring NATing. You don't get to do that anymore. So you need to have a slightly better understanding of how this works to understand how your containers talk to each other. Because as we talked about in the Thursday session, as long as things work, it's great. But the moment it fails, that's when you need to have a slightly better understanding deep down what's happening. And that's the deep dive we are doing here with container networking. And then we can do the same with Kubernetes networking also. We'll do that later. Now, what happens here is how these containers talk to each other is through a network bridge. It's a bridge. A bridge to connect. Bridge is typically to connect two things, right? You have an island and you have the mainland, and you want to connect them together, you connect through a bridge, right? So that's the bridge. So you basically have a bridge here, a network bridge, so that you can connect multiple containers and all of them are talking to through that bridge basically. There are bridges, there are routers. Routers are for different networks. Bridge is for the same, typically this is the same network and you just bridging the interfaces together, putting them in the same network. You can possibly, I believe, you can possibly do that with multiple networks also, the network bridges. But here we're just connecting with the same network, same IP space, same broadcast domain. And that is what you see here actually. So 172.17.0.2 is my first container. Let me launch another container and show you how they can talk to each other. And I'm launching my second container using the similar command, docker run -idt, hyphen name, this time NT02, and same image, same command. And now I have the second container running, which I can list using docker ps. Let me get inside that container, docker exec -it nt02. And you can see this is 1703, 1702. It is part of the same bridge. So they can talk to each other. That's how they connect with each other by default. This container is talking to the one on the right hand side. The right hand side can talk to the one on the left hand side using a similar command. like this. This is how it works. This is the network bridge. I can actually show you the bridge by running brctl. How many of you have used a command like brctl before to create the bridges, to examine the bridges? Yeah, this is the bridge we are talking about. And every single container that I create, I'll create one more just to show you how it works. So it creates a network veth pair. So I'll have three veth interfaces for three containers, and each of this is added to the network, same network bridge right here. For what purpose? So that they are part of the same broadcast domain and they can talk to each other basically. That's how one container will talk to another running on the same machine. That's how these services, when we launch it with Docker Compose or otherwise later, can talk to each other. Simple as that. This is one of the networks, one of the three networks which are supported by Docker by default. You can look at it by Docker Network LS, and you will see there are three types of networks: bridge, host, and null. There is a one more bridge because I created that for, or it got created as part of my Kubernetes setup, kind setup. So it has its own set of bridge and interfaces maybe, but mainly three networks: bridge, host, and null. There are these are the three type of networks which come with Docker by default. The none is like a black hole, so your container will not be able to talk to anything. So how do you create or put a container in a particular network? Is you can use hyphen hyphen network or even hyphen hyphen net and say I want to add it to this network whose name is none, and this has to be a new name. So now if I go inside that container, but which is none. None is NT04, none network, and that's done, right? So the other network is host network also. So how does a host network look like? Let's have a look at that as well. So I can put a container in a host network. Now this concept is also useful in Kubernetes, by the way. So Docker is a foundation to understand Kubernetes. So learn all of these things well so that you understand it later as well. And if you look at this has to have a new name. So every time I create a container, it has to have a new name, unique name rather. And let me exec into this NT05 to see how the host networking works. This is the host networking. What you're looking at is basically this time there is no bridge, there is no virtual interface. The container itself is connected to the host network, or also called as a root namespace, meaning it is listening directly on the host. So if you have a port 80 open here, your application is running on port 80 inside a container, it will be available on the host port 80 also. So it's like you're removing that virtual network completely. There is no network namespace at all in case of host network. That's why the name host network. Are there any questions? If you have any questions, feel free to stop me, okay, and ask. Instead of typing, you better ask directly as well. So this is the host network. So we talked about host networking, bridge networking, and then there is a um, none network. There are other networks also. You can find out using Docker system info. And you can find out the network drivers which are available here. So plugins, network, bridge, host, null. You also can create overlay. This is typically used by Docker Swarm for orchestration to connect containers between two different nodes. So this bridge works only or limited only to one machine, by the way. Okay, bridge is limited to only one box. If you want to connect to another box, another container running on a different node or a different server, you have to use overlay network or equivalent. MAC VLAN, IP VLAN, and special networks. So this has some special purpose. We're not talking about it, but it has some special purpose out there. So it is used only in certain cases where you want to connect your container to connect to the container which is running on a local network from a host outside host, not a container, a host from your LAN or over your corporate network and so on. So it has some special purposes, but mostly we don't have to bother about it. You don't have to know about it unless there is a very rare case scenario. So I'm not getting into that at all. There is one more type of networking though, which is useful for understanding Kubernetes pods. So when you look at Kubernetes pods, how are they actually designed, right? It's very interesting. And the way that works is basically in case of Kubernetes, you have a pod. Pod is a logical thing. Pod contains basically one or more containers which share the network namespace. How do they share the network namespace is basically there is another hidden container called as an infra container. It's a stopped container. Okay, it doesn't run. You can have a stopped containers also, by the way. And then what happens is these, if you have more than one containers in a pod, they're sharing the network namespace of that infra container actually. That's very interesting. So what essentially you can do is you can share the network namespace with another container. That is the key part that I want to emphasize here. How? Let me show you. It's very easy. I create a container normally. I'll call it as I already have this NT01, let's say, right? So NT01 is what I think I'm connected to NT01. Yeah, this one. Now, what I'll actually do is I'll launch another container, but this time what I'll see is, oh, network wise, I don't want any network of my own. I will connect to a containers network whose name is NT01. What that means is even if I get inside NT06, essentially I have the same IP, same interface, same IP, same hardware address that is called as a MAC address also. So it's all same, absolutely same, right? So how is this happening is because we're sharing the network between two containers, and that's what pods use actually. The pods are implemented this way. Even if you have one container in a pod, there is always an infrastructure container which is hidden, and that is purpose of that is to store these common namespaces, network namespace, host names, and stuff like that, right? So it's very interesting. And to understand pods at a deeper level, you need to understand these things actually. So that's where I'm adding this knowledge to you basically. Container networking. Is it clear how this works and how this bridges? This is a bridge network. Then we have the host and null network. And the network namespace is a sandbox. Sandbox is like an isolated environment, which is created by the container network management plugin. So there are two main standards in the world of container networking. One is CNM. Second is used by Kubernetes. What is that? It starts with CN, but it has a different uh, third character is different. What is that? When you use Kubernetes, we are actually creating a CN what? When we say we, when we say calico, when we say flannel, when we say, there are many network interfaces and network plugins that Kubernetes uses or supports. It is CNI. CNI is the standard in the world of Kubernetes. CNI was the standard created by CoreOS. CoreOS got acquired by Red Hat. Red Hat got acquired by IBM. So CNI, CNI is a part of CNCF now, but it's basically the network standard used by Kubernetes along with many others. Docker created its own standard called as CNM. And how did they implement it is a library called as libnetwork. And what happens is how the network namespace is created is basically network namespace is a sandbox. And then you have a DNS configuration, then you have interfaces, then you have the routing table, and all of that configuration is isolated for one particular container, what we call as a container. That's how the container gets its own configuration. And in case of Linux, it is through network namespaces. In case of Windows, there is a parallel technology because Windows is a different operating system. So they have a parallel technology called as network partitions. And there is a sandbox, then there is a endpoint. Endpoint is the network endpoint, in this case that eth0 inside the container, and on the host side it is veth. So it is the veth pair on Linux versus virtual NICs or virtual network identification cards, NICs cards, uh, by created by Windows, similar technology. And then the third thing is a network. So there is sandbox, then there is an endpoint, and that endpoint is connected to the network, and that network can be a bridge network, can be an overlay network. In case of Linux, it is implemented using Linux bridges. Instead of that, in Windows, it is vSwitch. So some technologies which are different, and that is what makes these containers networking and the namespace work actually at a very high level. Any questions with networking? Because then I'll start talking about Docker Compose. I'll start talking about how to connect this service with this one, this one, this one. And I'll show you by building some Docker Compose spec as well, which is very easy, very straightforward, very easy to work with, right? And then I'll show you how to use AI to do that as well, right? So Docker Compose is a technology which allows you to connect or launch and automate and codify the launch of a complete development environment on one host. That is important because beyond one host, you can't use Docker Compose, you have to use Kubernetes. But Docker Compose is very, very useful for that single host launching of multiple services and so on. And a good example that I typically give is Prometheus. Let's say Prometheus, you want to launch it, you have multiple services that talk to each other. It's not one single tool with Prometheus, right? So Prometheus is a time series database. Then we have network node exporter, which collects the data from everywhere. Then we have Advisor, which is monitoring the container data, kubestate metrics in case of Kubernetes. And all of these are like feeders of time series data to Prometheus. And from there, we have Grafana, we have Alert Manager. And those are the services which will help us to kind of go and set up this entire monitoring ecosystem. And if you want to launch it, either you're launching 5 different containers, or you can just do this saying that, hey, I want to launch Prometheus. I want to use Docker Compose for that. So I'll search for Prometheus Compose spec, and it's all code. It is all code. Okay, that's the best part. And if I have a Docker Compose spec, I'll show you the Compose spec later, but I'll also show you how to write it. But the use of this is here. Basically, this is how you use Docker Compose. All I have to do is, if I have the code, assuming this is the code, Docker Compose spec, that is, I'll just go here and run, let's say, either earlier I used to do this Docker Compose, Docker/compose was a different utility, but now Compose is built into the Docker CLI itself, which is a good thing. And all you have to do is just this Docker Compose up -d, wait for a couple of minutes. It just sets up everything, the entire microservices stack with Prometheus, with Node Exporter, with Advisor, with Alert Manager, with even the Grafana. Everything is being launched and set up automatically. And this is the best way to launch your dev environments as well locally with multiple microservices. And that's where you automate it as a DevOps practitioner. You also are responsible for creating these Docker Compose specs. And this is, we are talking about the microservices now with machine learning and AI. We also take models and other tools and all that, and we can package them together into container image and create a Docker Compose spec for that. So it is also relevant in the world of AI. I keep on emphasizing it because now we are in the age of AI, so we should be aware how things would work there as well. The software will change to model, more resources, more maybe required as well, but the concepts remain same. So it's Docker Compose PS. You see the environment is set up. completely. 5 services have come up, and I can show you by logging into Grafana, which is running on port number 3000. Just trying to find the IP address. This is a public server, so I'm just trying to find the IP address and go to 3000 and just trying to see what would be the default password. I don't remember this, but it may be somewhere here. I used this particular code for Grafana. The yeah, password is foobar. It must have been configured somewhere into that spec. And typically, this is something you should be able to change as well. But my point is, you have a complete environment up and running, even with some dashboards and stuff out there, right? And this is connected to the backend. So this is a Grafana. So when you set up from monitoring, this is typically what you will use. And this is typically connected with the data source, which is Prometheus. Yeah, so all of that configuration is already been done with Docker Compose also. So there is a service discovery. Realize this, right? These are multiple containers launched on the same server. They are connected together for alerting, for dashboarding, and for everything. And then we have the configuration where it would have now the configuration seems to have changed. The place where you configure the backend actually data sources is yeah, this one. So it is connected. You can see that it's connected with a host name called as Prometheus on port number 9090. The Prometheus host name is part of the Docker Compose spec here. So this Prometheus host name is this one. It's part of the Docker Compose spec. There are 5 services. Each service has its own block, how you launch it. And that is what goes behind the scenes when you create the Docker Compose. And the good part about this is Docker Compose down or stop and remove will just clean up the environment for me. This is nothing was installed on the system. Remember that. So I can move on to work with another project as well. So I typically keep one dev environment. So you can see all my projects are here. Okay. I keep one environment with Docker. I use that to set up Kubernetes sometimes. This is my Docker environment. This is another project I'm working on. But I use this to set up an environment. I can bring it up, bring it down, clean up, move on to another project, and things like that, right? So that's very easy. So Docker Compose makes it super easy to work with any multiple project. You don't have to have multiple VMs or multiple servers set up. You can just work with one environment and you can work with multiple products. And those are the advantages with Docker and the ecosystem overall, right? Your workflow is much more efficient now. Now, how do we write this spec is where I'll start showing you the code and how you can create it, right? And I'll do that for the same application, this application. And here there is Docker Compose. I'll remove it and then I'll create it again from scratch. But you can use that as a reference. Okay, I'll start writing. Typically, the file name is docker-compose.yml. That is the default. You can change the name. That's fine. You'll have to just reference that name in every command. But otherwise, you can change it as well. And how do I write the spec? It's very easy. It's a YAML. YAML is like writing simple English language statements. Just that you have to be careful with the indentation, which is typically 2 spaces. Don't use tabs. Just indent it properly, as in organize it properly for readability, and you're sorted. How do you write this spec? If you want to understand that, we have entire documentation on that. So Docker Compose documentation, you can look up, and Docker Compose file reference is what we are looking at. And that should show you this seems to have changed a little bit. This is for versioning. Now I think they have created different sections. Yeah, this is good. So this is how you write the services. So these are basically microservices, right? Each of this is. the board, see, I will refer to this diagram or this diagram, it is the same. So vote, Redis, worker, DB result. There are five services, vote, Redis, worker, DB result, right? So how do you write the spec for that is basically I'm writing how I want to launch this, meaning I'm essentially what I'm trying to do is automate or write codify my launch command like this. So docker run hyphen idt hyphen p, and then I'll say I want to launch this on connect this on 8000. This is the port. This is my image. This is the tag and blah blah blah. So there could be 10 different options here. So basically, if you want to convert this into code, how will you do that? That's how the approach we will take. So I'll take this command and convert it into code. This simple statement, docker run command, how do we convert it into a docker compose spec is what we look at. So I'll go here. I'll go to this spec, start writing docker-compose.yml. What do I write? Earlier, you had to start with version. That is deprecated. You don't have to write the version because multiple versions were there. We started with Docker version 1. I started teaching with Docker version 1, Compose version 1. Then came 2 point something, and then came 3 point X. And then after 3.8, it doesn't matter. So now we just don't use version because there's only one version. So all we have to do is service, like the spec I showed you, the documentation that I showed you, right? Services, basically. And then you write whatever microservices you want, right? It has already indented. I think two spaces needs to be there at least. And then I can start writing whatever services I want. In this case, the service name is vote. And then everything related to vote. How do I want to launch the vote? Using this command. So what do I have here? I have a few things. One is an image, which is here. This is an image with a tag. I want to define some ports. Ports is an array. If it is an array or a list in YAML, and this is true for Kubernetes as well. Even Kubernetes follows a similar thing, YAML syntax. And if you want to write YAML, you should just understand this a little better. So if it is a list or an array, it is written this way. And then I'm defining the same port mapping right here. That's all I have to do. Okay. You can use the reference of this here. Now I think I have to quote it for better because the color code changed. So I just better do that. What else do I define? So this is actually everything that I need. See, this hyphen IDT is assumed by default. Minus P is what we are defining with ports, and image is defined. I don't have any command or anything else, but anything else that you want, it could be environment variables, right? So it could be environment variables, it could be some resources, it could be labels, it could be network configuration. Let's add a network configuration here. So I can create a network, a custom network, and make this part of that custom network, right? So just like services, I can add networks. I can say this is the network called as InstaVote. Uh, the driver for that network is bridge. Basically, this is equivalent to saying Docker network. There's a command for Docker network create actually. If you use Docker network create, right, this is the syntax for it. Docker network create. Then you have options and then the name of the network. Name of the network is InstaVote. Options are typically a driver. One of that is the key option is driver, right? The driver can be bridge, a host, none, whatever. So you can define that as a driver here. And this is gonna create an isolated network. This is why you saw when I showed you Docker network ls, you saw a new bridge. It was like isolated network created just for that stack, right? And that's what I'm trying to do here. So I'll create a different network for this stack. And then this way I can add any number of services. So I can say Redis and then say Redis Alpine, what port it runs on. I'm not exposing it, so I don't have to care. I may have to put this in quotes, okay? Just gonna look at, no, this does work. So here it's showing me some, this looks okay. You can also say, oh, you can set up dependencies saying, oh, this depends on. How do you know all of these primitives? You can just look up the documentation. So this just does the sequencing. You can look at the documentation here and you'll find most of these, including the entry point, domain. You can also provide IP addresses. Depends on is there, right? So you can say, oh, my service depends on Redis, also something else, and you can keep adding those kind of dependencies here. It is as simple as that. Okay. Just try to write it once, right? You should get an idea about how this all works. And then you can start using AI if you want as well. AI assistance is something that you use only when you're comfortable and understand and you can own that code. Then you can use AI, right? So, in my opinion, that's how you should approach. Now, set up two services, they're connected to each other. I will show you how this works. Docker Compose PS. So first two services are up. My main service is running on 8000. The backend service is Redis, which is running on 60. Internally, that's connected, so no problems. So the application code, how is it connected? Is internal service discovery works like this. So when Vote wants to connect to Redis, it is going to use the host name as Redis, which is automatically resolved by Docker Compose because there is a service discovery built into it. What I'm talking about is when Vote wants to connect to Redis, it's using hostname Redis. See this one, the hostname Redis. How does this work? We're not using that. Typically, we connect services or web server to database using IP address or something, right? We don't have to do that here because this will automatically get resolved because something interesting is happening here, and that is when you create services with Docker Compose. So I have a service called as Vote and then Redis, right? So what happens is, let's suppose there is a DNS table. So each of this service gets added to that DNS entry, Vote, and then Redis, and its IP address, whatever it is. And the interesting thing is, this can be different on your machine. This IP address doesn't have to be same. It can be 172.18.50.2, but this will still work because Vote is connecting not using IP address, but using the host name. So that host name, Redis, will be resolvable. I will show you that actually. How that works is uh, this way. Let me first also stop one of these services. So Docker compose stop Redis. Docker compose PS 8000. Yeah, it does work, right? Now, it is not connected to backend yet, okay? So it will fail eventually. Why? Because it's trying to connect to internal server errors because it is trying to connect to the backend service using the hostname Redis, which is not available because I just stopped that service. So if I go inside and now I can use Docker Compose exec also, and then I can just use this name of the service and then get inside, right? This is where I am. This is my IP, something. So it created its own network, by the way, its own bridge for this particular stack. And then if I'm trying to do, I can just do ns lookup for Redis. Cannot resolve right now. Okay, because the service is not up. Now I'll start it. Okay, and now that the Redis is up, it will eventually start resolving once it comes up. Yeah, okay, let's see what happened here. Yeah, am I inside what application? I am. So it is, I think, via some special service. Let's see. Still not able to resolve, but I think it is trapped by, let's see. So now I'll refresh and show you. If it fails with an error, it's not running, it's not connected. I think I know the problem. I made a mistake in my Docker Compose spec. Why it's not able to resolve and connect, even though it's part of the same stack and all of that Docker Compose spec. Any guesses? There is a mistake or something missing, a configuration, which I've done somewhere but missing somewhere else. I'll give you some clues. The IP address of vote is 172.2.19.0.2. But for Redis, it is 20.0.2. Okay, is there a problem? What am I missing here? You can put your troubleshooting hat on. What is it that is missing? I gave you the clue also. This is Redis, this is vote. Let me give you one more.
Networking.
Yes. So do you see what is happening here is for Docker Compose, it created, because of this, it created its own network called as Instaboot. But now what also Docker Compose does by default, it looks like this was not the case earlier, but it creates its own network now, which is this Docker network inspect. I will say this is the network. This is that /20 network that Redis is on by default, right? And there's only one interface here. You can see that is Redis. What should have happened here is since I put it in a network called as Instaport, if I want these two services to talk to each other, I have to have this as part of the same network, right? By the way, you can put them in multiple networks also. Okay, that's also possible. So you can say default and Instabot and whatnot. You can have that as well. But it should be in same network. At least one of the interfaces has to be in the same network. So how do I update is very simple also. So all I have to do is just do docker compose up -d. It will replace wherever needed. It should be networks. Will replace whichever container, whatever is needed. It's smart enough to know what to do. Okay. And now, if I show you the same command, this is a brand new container in the same network as the vote application. And because of that, if I run the same command, ns lookup redis, now it works, right? It has to be part of the same network in order for it to work. And since it works, it will not throw an error. This time, it will just show me a check mark, which means it's working. So what we got is two services connected. I'll just go ahead and connect worker DB result. I can either integrate with Dockerfile or use the images. I'll use the images right now, okay? I'll use the same images that I have. You can also use like, okay, I have this, and then, by the way, have you tried image with something like ChatGPT? ChatGPT understands images, okay? For debugging, for uh, understanding, making them it understand and all that, certain things, it can work actually. So I can say that this is my existing Docker Compose spec with two services. Can you write me the Docker Compose for all five as per the diagram, right? And then as per the image or as per the diagram, whatever it is, and I can just take a snapshot of that. I do this a lot, okay? And this is the traditional machine learning OCR, the image recognition. Then it integrates with the Gen AI, which is a large language model, foundational model. So it's a combination of machine learning and the LLM both, right? And then I need to provide some images and some things, right? So let's say for worker, um, and then result and DB, use the following images is what I would say. So School of DevOps slash worker, database will be Postgres, let's say 9.4, and something on that line, right? So I'll just take whatever I have already as images. And let's see if we can have a nice Docker Compose spec here. Okay, this is my worker image. This is the result image. I think that's correct. The port expose result on port 8001. Use all the best practices while writing Docker Compose. Let's see what it gives us. So it actually recognizes this image, okay? And it will write the compose spec for all. So, and let's examine this version. See, I don't think it's been updated with the latest thing. So this will show a deprecation warning. So this is something you'll just have to understand and know from your experience. But otherwise, it has done a decent job. This is a good job. It has already picked up the or has written it with Docker file in mind. This is the for result, which depends on Redis, and this is good because then let's find out if result depends on Redis and DB. As per this diagram, result depends on DB. Result does not depend on Redis, so that you'll have to correct. Worker depends on Redis and DB. This is correct. Worker can have this environment variable. This is good. We may not use it, but that's fine. Everything is part of app network. Redis Alpine is a lightweight Redis image. That's fine. This is not needed. We don't have to expose Redis services. Generally, these services, backend services, don't need to be exposed outside the host. Anything except for vote and result doesn't need to be exposed. But again, you'll have to provide that as a context. It's just giving you a decent file to start with, and then you can modify it. Let's see how we can modify this, right? I'm just going to replace my existing Docker Compose with what GPT gave me. I can't use actually this one as an image. This is wrong because my context is fine. My context is vote as in this is a microservices stack, and the it is expecting the Docker file to be inside this vote path, and that is fine. I'm okay with that. Uh, but when I build an image, it won't be Python something. It will typically be something like vote, or even better will be, because it's for an application called as vote, and then whatever the, let's say the image when it is built, right? It is going to be tagged with this basically. So this is the tag which is going to be used. So this has to be typically your name. And this explains where the Docker file should be. So assuming the Docker file is in that directory, which is good. Uh, Ports it has not picked up because we didn't provide the context, even though we provided the Docker file. So it didn't consider that actually. Or I did not, I did not provide the Docker file. That's why. So that is understandable. So if we provide our style, our code, this can work better actually. But this will be something like 8000 colon 80. And that's probably the reason it created a network called as app network. Yeah, which is driver bridge. So similar to what we had. This sequence doesn't matter. The network can be after services or before services. That's fine. It doesn't need, if application uses Redis stores as an environment variable, then you need it. Otherwise, you don't. But this is as our setup. Plus, we have a build. Uh, I'll tell you where this is useful. You can also have a name for the Docker file, which is Docker file or something like that, which is a name of the Docker file. If it is different than your normal Docker file, something, you can provide that as well. So that's another configuration you can add for the build. You can also provide architecture for the builds and all if you have multiple architectures and so on. Result 8001 is fine, but the host port, container port is 80. Result does not depend on Redis, so I'll remove this part. Worker depends on Redis and DB. Worker does not need environment, but if it needed, this would have been useful. And worker has this image that I provided. Redis is Redis 6 Alpine, no problems with this. This is needed only if you want to expose the ports to the outside world, which is not needed. DB again, we don't have to expose it. See, internal communication on 45432 when vote or result wants to connect to this, that anyways works. So that doesn't get stifled because of you not exposing it to the outside world. So this something like this would work, minus of course the version. So fine. I mean, GPT gives you decent code, but it needs to be slightly modified to make it work. Also, you'll see a deprecation warning with this one. Let's give this a try. So let's say Docker compose. Uh, Let me first build it. Okay. When I say build, it is going to look up the Docker file in that vote application. See, the version is obsolete. This is deprecated. And it has built the image also. So this image was built and tagged with whatever tag I provided. This is why it was important to provide our own tag here, not Python. So I'll tell you what would have happened with if I had used Python something. Let's say Python 3.9, right? This is not correct. I'll tell you why. Also, this I'm gonna remove. So what happens now is it builds an image as Python 3.9. This is not the right one, right? We're not using that as a base image. So I think that ChatGPT, the knowledge base it is using, had some flaws, at least when it created this one. So it has to be slightly different. I mean, this needs to be modified for sure. Okay, this won't work like that. So school.slash vote. What probably would work better is if you're trying with AI, VS Code with the Code extension should work better. Actually, writing Docker Compose is not very difficult. Okay. But in case if you want to write it with AI, let's have a look at how AI can help us write this better. So what I'll do is I'll create a new file and give it a name called as docker-compose.yml. And I will put it in a different path. Okay. Now let's see. It has detected, one is it has detected my uh, language. The language is Docker Compose, which is good. And now I can start writing services, which is good. Perfect. Since, see, it has the context. What is the context? The name of the uh, directory in which this file is, which is vote. Based on that, it has picked up, oh, it has guessed that service has to be vote, which is fantastic. The next thing is typically an image. Yeah. And then image has to be our, I think maybe they have the context from Code Cloud, which is good. Uh, School of DevOps slash vote. Ports, you can do it this way, or you can put it in there. I think I would mostly use something like this rather than using GPT, which is better because then it gives me what this is supposed to be. Redis. So it has that knowledge. I think it knows about that example voting app. It would have definitely it would have scanned it because it's a very popular application you being used by a lot, and this just lets me complete. Wow. I don't need ports here. I just need networks, which would be my own network name. It has to be backend, or let's me call it as InstaVote. I'll have to put the same thing here as networks and then same InstaVote. It detected that. That's perfect. Now, do I have to provide anything else? What does it say? Networks. Yeah, perfect. InstaVote. That's perfect. Driver is perfect. So I would prefer this. This is a extension which is connected to my Open API using a tool called as Kodi. That is what you see here at the bottom. And this helps me complete the code. And this is what I would really use, right? Not something like this one, which I have to edit quite a lot. If you want to use, so do this with the AI. I think something like this or using GitHub Copilot might work better for you. Cool. So that's that. And let me launch this entire stack, Docker Compose up -d, and it is bringing up that entire stack of services, which should be interconnected as well with vote, worker, DB, result, and whatnot. Yeah, this is done. Services are up. 8,000 is vote. 8,001 is the same 8,000 thing. Maybe just a different version of the application. Possible. Yeah, it is not. Yeah, so a different version of the application. That's possible. That's fine. And this should, if it is connected to Redis, it will work. And then finally, this is the result application. So if it is giving me this error, there is definitely something wrong between, yeah, you can actually see what's wrong. Something is wrong here. Two of my services now have not come up. that includes Redis, and that includes DB. So maybe something failed. So this got exited, this got exited. If it has exited, there is something wrong with it. So I will check the logs part here. Let's also check. This is database. This is Redis. 751. This is Redis actually. I think it's expecting some Redis server. So it's trying to create master slave configuration, I think. So what I'm gonna do is change this Redis to just Redis colon Alpine and image. Probably this particular version of Postgres requires you to provide some password. That is a possibility. Let us check that. Right? You can also use Docker Compose logs since we are running it via Docker Compose. So it is expecting a password, which means it requires you to provide this or set this to trust so that it doesn't ask for a password. So what I'll do is if I have to add an environment, right, I have to do something like this for a DB, that is name and value. So this is what I'm going to copy and or not copy, but I'll just add a similar configuration here for the environment. So I have to use either this or this. There are a couple of different ways of providing this. Okay. You can again look at Docker Compose reference. So this is one way. This is one style. There could be other styles also. You can look up Docker Compose and find out like, oh, I want to provide environment. So environment can be this way or it could be this way. I'm using a wrong combination. So I should have used, I'll tell you what are the right combinations here. I should have either used equal to here, or if I want to keep it as colon, which is a dictionary, then I should use this. So these are the two acceptable methods. And now if I run, uh, see the same command takes up the changes. So this is DB environment has to be a mapping. After the colon has to be space. So it is relaunching worker and worker because of the, I think the dependency also. It's stopping that and it's launching again everything. So you will have to be ready with these kind of troubleshooting stuff. And now that it is all up, you can check that by using docker logs -f or docker logs. Yeah, so the moment you see processing, it was waiting. This is the worker. Worker logs should say connected to DB, connected to Redis, processing the vote. Means all the connection is up. This is typically for this. This is the troubleshooting. So if I go here and show you, worker is the key connector. Worker is connecting to Redis. So this side and this side is all connected via worker. So the moment worker says I am connected to Redis and DB and processing it, this should be automatically be available. This should be available, which means my vote application should be there. I should be able to submit the vote and that should reflect here. It only shows one vote but it shows one vote. That's good. And that is because it's tracking the session. So if I want to submit more votes, I have to be incognito or use a different browser. This is HTTP. It expects me to have secure connection. Let me try different browser. Should allow me to submit the vote, which means I have now two votes added. And then if this would have supported, it does support now. So I have three votes now. And then if I change something, I should. So I have to use a different browser or incognito window if I want to get more votes. But the idea is this all is connected, and I've launched it with Docker Compose spec. And Docker Compose allows me to create this environment very quickly. And at the same time, I can also do Docker Compose stop. I can start it back again, and then I can also kind of remove this completely if I want to using Docker Compose RM. And then there is a command called as Docker Compose down, which does stop and RM in one go, right? And it's cleaned up along with the network. Now the network is also cleaned up. So you can see it has no trace of my previous containers. These are the ones I launched for network testing, but my Docker Compose, everything is just gone. Any questions here? Okay, it's all cleaned up, all my Docker Compose. So Docker Compose is a very effective tool for creating these kind of environments. We also use it to launch, let's say for CI/CD sessions, we will use Docker Compose. I'll show you my code. So for CI/CD session, let's say we want to set up Jenkins. How will we do that? We will use Docker Compose to launch that setup. So this is the Docker Compose spec. It has also a Docker file. So we'll create our own network. We'll have some volumes for so that we don't lose the data between restarts, or even if we delete the containers and create them again after 6 months, you'll have all your Jenkins jobs out there intact. And what are the services? We have a Jenkins, we have Docker, and this is all connected to each other. So this Jenkins service, the reason why we have a very long spec is because the Docker run command equivalent would be very, very long. It would have the image, it would have the ports, couple of ports, environment variables, networks, some volumes, dependencies, rest of the configuration. That's why it looks long. And that's why this code is important, because then you can, I've written this code few years ago. I don't have to remember anymore. I don't have to document anything anymore. I can just give you this code and you can set up the Jenkins environment in a couple of minutes using a couple of instructions with this code basically. That's what we use Docker Compose for. And then for development environment automation, this is very, very useful. Very important, very useful tool for development, that is. Right? So you should understand networking, you should understand Docker Compose. And once you go through this through the course, so what are the topics you have to go through for this week? So essentially, you go through this Docker Compose, Docker course. I'll tell you which ones to look at. Building container images, you should have learned already. So container networking and storage, go through that, and Docker Compose. That's it. And then if you want to do some interesting stuff, you can use this as a application project, right? Mini project. Plus, you can also go through our Reddit community of DevOps builders, where I have published the project number 2, which is about that craftist application. And if you do this, you'll be very, very good with Docker and Docker Compose for sure. Okay. You'll have a good product built. This is the application. This has multiple services. And if you do it for this, you understand how to work with a Node.js, Python, Java, Golang. So it covers most of the important stacks. And this is a good project to do as well. So if you build this project, post your code of Docker Compose file, that is, a link to that here, and I will review it with you maybe sometime one of these weeks. Any questions, folks?
I have one question, Gaurav. Is there any way we can define the network globally, which every services will going to use, rather than defining again and again?
See, network, it's not mandatory to define it. What that means is, let's say here, right? This is what we are talking about, networks, right?
Yep.
So what happens now? We'll find out. So I'm just going to remove this network configuration.
Mm-hmm.
There is a network created automatically by Compose. So we don't even have to do this. I just showed you to show you the configuration that you can make. And if you look at Docker network ls, right? Let me delete all of these so that you exactly know what's happening. Docker network rm, and we'll remove this one, we'll remove this, and we'll remove this. So we're keeping only the default network. There are three default networks: bridge, host, and none. This is the default bridge network anyways. And what happens now is we don't have any of that network configuration at all. So I'll have to remove it from all services. Sorry. No network configuration. That's fine. It will still create its own network. This is the global or a default network that we're talking about. It's not a global network per se, but it's a
Mm-hmm.
default network configuration created specifically for this particular stack. So it's already happening. So you don't have to necessarily do it anymore. This used to be not the case earlier. Earlier, what used to happen was if you don't define the network,
Mm-hmm.
everything will be part of this default bridge network. This is the global network that we're talking about.
Okay.
If you want all of these services to be part of this global network, I'm pretty sure there will be a configuration here. Now that it does it this way, but I'm very
Mm-hmm.
sure that there has to be a way to override it with Docker Compose up somewhere.
Mm-hmm.
And if you look at the help option, I'm pretty sure it has that option somewhere to override or something like that and just make it part of the default network and so on. So it's already happening, even if you
Mm-hmm.
don't define it. The network is being created, and that's an isolated network just to for these services to talk to each other, basically.
And for the volumes you have mentioned, like if we delete the Docker Compose also, like everything will be deleted. But if
Not
we
true.
rerun it, the volumes will be still there. So
Absolutely.
what space the volumes are using? Like it's local machine, like the where we are going to run it, it will store in that place only. I want to understand more about which directory it is using, because it's,
I'll show you.
yeah.
So, where is it stored and how is it done? We're looking at that, right?
Yep.
Let me show you what I mean by this volumes and stuff, right? So, actually, let's just create this if we can. We do have time. So, let's say we create a setup for Jenkins. So you'll actually see what happens when you delete the setup and all of that, right? So here I want to launch a Jenkins system. So all I have to do is git clone this, get into bootcamp Jenkins where there is a Docker Compose file. Here I'll say Docker Compose up hyphen D. I want to build in the process, so the build will happen automatically. While this is happening, I'll explain the volumes and where they are created and how it works conceptually first. Then we'll also look at the system. So where is it actually creating the volume? Where the storage is happening? It's on the Docker host. What do you mean by Docker host? In my case, it's very simple to explain because I have a remote server running on DigitalOcean. This is my DigitalOcean droplet or a server. This is a Linux server. So think of that as a VM on cloud. And this is my Docker host. This is where my Docker is running, Docker daemon and Docker server and all that. And then I create containers on top of that. And what happens is it creates a volume, as in it will create a path, some directory on this server, some directory on this server will be used as a volume, which is mounted to one or more containers, and that's the typical volume configuration. And what happens is whether you have it created with Docker or Docker Compose, it doesn't matter. Even if you delete these containers, the volume will still be available. Meaning, if you launch it with another container, let's say you deleted the containers, you don't need them. You came after 6 months and said, "Oh, I want to use the same jobs and I want to continue learning Jenkins or using Jenkins." You can launch a container with the same volume that was the Jenkins data, and you'll have all your jobs intact out there. Actually, it works like that. So, where is it actually storing it? That is the question now we're going to answer. I'll also show you first how this does work, because my Jenkins is up and I can configure it quickly with maybe one job. So this is Jenkins, and then I'll say I have to provide some passwords. So it gets added to the logs here for Jenkins server. And then I can quickly configure the plugins. All of these plugins are getting installed. That's part of the Jenkins installation. So you will notice that when I delete this container and bring up a new one and connect to the same volume, I don't have to go through this process again. It's just one time process. The username that I'm creating here
Mm.
will also be there. So where is it being stored is in the volume. How is that configured? I will show you. First, let me uh, just show you this one. Okay, this is done. I'm using Jenkins. I'll create a job. I'll call it as a test job. I'll say this is my pipeline project, and I'll just use some sample pipeline script. Okay, so I've run a job, created a job. I may want to run this. So this is some configuration being stored somewhere that is stored in on a volume. And then I'm gonna run it a couple of times. Shows me some execution and stuff. Right now, why doesn't show me the actual pipeline view and all that? That's some plugin which is missing. But you see a job, you see some configuration, it has executed. I can also go and check the logs. So it's done something. Now, this is some data which is generated, and configurations, data, and everything. Where is it storing it? Is the volume. How do I find out where the volume is? It's in the Docker Compose spec that we used here. So the same Jenkins Docker Compose. So you see here, there are a couple of volumes. One for search, one
Yes.
for Jenkins data. This Jenkins
Yes.
data volume is what is mounted to var Jenkins home. So everything, including the plugins, including the jobs, is being stored in var Jenkins home, which is the actual volume. Where is this volume? Now, let me answer that question. That volume is right here on the Docker host. Where it is? It's on the Docker host, as in it could be a VM, it could be something running on your Windows machine, or in case of Mac, it could be a VM, right? So in case of Mac, typically this is your Mac, and within your Mac system, you have a VM created here, and that is your
Yes.
Docker host. In case of Windows, it is a WSL2. So it's not a VM, it's some subsystem of Windows called where there's like one room. It's a kids room, for example, in your home, and there you have everything for kids, right? So it's like an isolated environment for the kids. Similarly, one corner of the house in Windows is dedicated for Linux. So the theme is Linux. The moment you enter there, you'll see everything related to Linux basically, and you can execute that. So that's a WSL or Windows subsystem for Linux. No matter where that is,
Mm-hmm.
it is basically that is your Docker host. And on that host, you have this path where the volumes are created. Where is the volume? Let me show you. This is the volume, Docker Jenkins data. Jenkins data volume, if you want to find out where it is typically there is a var lib overlay, var lib Docker. Okay, let's find out. Let's inspect this. Docker volume inspect. You'll find the path. Where is it? Var lib Docker volumes. And inside this directory, all your volumes are actually. So this is just a local storage on that host. If I
Okay.
have a Linux server, this is where you'll find all the volumes. And that volume would also have this Jenkins data. If you go inside this, you'll actually see, you may see some data. Yeah, this is where the data is, actual data. This is where it is. Okay, so Docker, varlib Docker volumes.
Okay.
This is the default.
Hmm.
What else is possible? Docker system info will tell you that. Just like network can be different types, you can
Yes.
also have volumes which are of, no, this is volume is local only. So there's only
Mm-hmm.
one local volume supported right now with Docker, and that is where it is, which means it will always be in Docker volume ls, unless you're using like Kubernetes will support network volumes also. But here we have just local volume, which is under var lib Docker, which also has rest of the things. Like this is where your images are stored. Overlay 2 is the storage for image layers. Each of these directories is a layer in your image. This is where your containers are also stored. Containers, if you create any files on a container, running container, they are stored here. So this means that I may have these many containers actually. So yeah, these many containers. Each of this has its own path and all that. And similarly, the volumes are also stored inside this. And why volumes are important is because I have this data, and then what I'll do is, okay, on the same server I'm here, this is where I launched everything from. I can just say docker compose down. This is deleting my containers, network containers, so that Jenkins container is gone completely. Can remove everything actually. PS minus AQ. I've cleaned up all my containers, so that's gone. But what happens is the next time I bring it up, I can also take this moment to upgrade Jenkins, by the way. I can just say, change the version of Jenkins here. I can also upgrade Jenkins, but bring up the same jobs also. So instead of 2.387.3, so this is one way of upgrading Jenkins with Compose actually. It's very easy. 2.87.3 is the one I have. Let's say if there is a newer version, right? So this is a few months ago. 2.493 seems to be there. But no, I want to use an image in the Docker file actually. It has to be 491 JDK 17. Now I have 493 JDK 17. So I'm upgrading the Jenkins version also now. This is where it gets interesting because you can actually upgrade the version of Jenkins but bring with the same data and all. So what I'll do is Docker compose up build by building, and I will only bring up Jenkins, let's say. This is actually building a new image. It will then launch it again. But the plugins and the configurations will be from the storage because I'm using the same volume mount. See, ultimately, it will take the same volume, which is already available, mount it at this location, which means my Jenkins is upgrading and I'm bringing it up again. But it's going to have all my jobs, plugins, everything intact. So sometimes if you have been using Jenkins for a while, of this, there is a bug. If you want to upgrade, this is a quick way of doing it without losing anything, any data or anything like that. If you're doing it with Docker Compose, this does take some time because it's installing a bunch of plugins like Blue Ocean, Docker Workflow, and whatnot.
Yeah.
And it started now. So what we have, the reason why you should be using storage volumes is because of that. Otherwise, we would lose all the data and we have to do everything from scratch. Like if we had created 10 different jobs, multiple pipelines, all of those would have been gone. Here, everything is there. Uh, I'm using the same username and password, but I've upgraded to 2.493, but my jobs are still intact. That's why you need a volume, and that's how the volumes do work. Uh, and that's the advantage of using it. And let me now delete the volumes and show you what happens then. How do you delete the volumes is the containers are gone, but not the volumes. Volumes will remain intact. That's why you see a bunch of volumes. These are from my history of creating containers and all that. And until I explicitly delete the volumes, it will remain actually. And the moment I delete the volumes, now if I bring it up, it has to start from scratch now. So your logs. So sometimes you want to reset it completely. This is what you'll have to do. So docker compose logs minus f. Sorry. If you have to reset, you can't just delete the container and bring it up. You have to start from by deleting the volume, and only then it will start from like scratch. And then I'm starting again. Now it's asking me to install the plugins and do the configuration and blah blah blah. So that's the difference. So volumes are there to store the data, make it persistent, and then that has its advantages actually. And this is how it works. It just gets stored on one directory on the system. That's how it works.
Um, okay. Yeah. Now got it. So can we scale up this thing also? Whatever services we are running through Docker Compose, can we scale up these also?
See, you can, but it has no meaning really, right? Because how much can you scale up on one system will have a limitation always, right? So you may launch two or three or whatever, but then you don't have a by default you don't have a load balancer like Kubernetes has a service which acts like a load balancer. That's not there. Secondly, it'll always be a limit. So you don't use Docker Compose typically in a production like environments. You would
Okay.
use it mainly for development. So if you want to really provide the scaling and all of that, we are typically looking at containers running on multiple nodes, and we need to have a orchestration engine. The need for the orchestration engine like Kubernetes is just that, so that we can take it to the next level, run the containers at scale in on different nodes involved. And that has its own challenges because now we are talking about how do we connect the containers on different nodes together, how do we orchestrate it, like how do we decide where to run what, and how do we take care of storage which has to span across the nodes and various other things, right? That's where Kubernetes does a fantastic job, and that's why you need Kubernetes.
Okay. So Kubernetes also underlying using Docker Compose only.
No,
No.
it doesn't need to because Kubernetes has its own orchestration pieces. It's very sophisticated technology. There are many components out there available with Kubernetes. So
Mm-hmm.
Kubernetes doesn't use Docker Compose. Kubernetes, in fact, does not even use. Docker anymore. It used to. So
Mm-hmm.
on Kubernetes nodes, we have alternative runtime. Docker is just one runtime, one of the runtimes, and Docker
Okay.
does more things like image building and all that. But in
Yes.
Kubernetes, all you need is just running containers. For running containers, there are lightweight runtimes. For example, Docker internally uses what? Docker internally uses containerd. So you have runc. Runc is always underlying thing, but it's containerd actually.
Yeah.
So with Kubernetes, you directly install containerd and use it. That's one of the runtimes. The other runtimes, which is closely tied with Kubernetes versions, and it also works very well, is
Mm-hmm.
CRIO, because CRI is a container runtime interface for Kubernetes, and then CRIO is the runtime. So you can use CRIO or you can use containerd as your runtime. So in Kubernetes, there is no Docker, but it does not mean Docker is not relevant. We still use
Mm-hmm.
Docker in development, build the images which are compatible because it's the same
Mm-hmm.
standard. It's called a CRI.
Okay.
CRI defines the standard and is the same standard which is used and followed everywhere. So you can use build an image with Docker, run it with Podman, run it with any of the runtimes that Kubernetes supports like CRI-O and Containerd. It's a standard way of doing things. I hope that was useful for you. If you've stayed till so far, you've definitely, I believe, have learned something out of it. So do subscribe to this channel and do let us know what are the things that you would like to learn from us. And that's it from my side. This is Gourav Shah from School of DevOps, and this is our Open Learning series.